All right, hey honors chemistry. So the last things that we'll be learning in this unit is something known as empirical and molecular formulas. If you remember, the title of your zinc chloride lab that we're going to have to push to the side for a while is known as the empirical formula of zinc chloride. So we've already determined the percent composition of elements in the compound from their formulas. Formulas that we typically work with are formulas that have the simplest whole number ratio of atoms. These simplest ratio formulas are known as empirical formulas. Okay, so that's our terminology. Also, empirical means experimentally determined, experimentally found or determined. That's going to be a vocabulary word that you see in the future. So whenever we figure out formulas, like from our lab that we're going to do, it would be an empirical formula. So H2O and C3H8 are empirical formulas because the ratios of these elements are in their simplest form. So if you look at H2O is a 2-to-1 ratio. And if you remember from electrolysis of water, water splits into twice as many hydrogens as it does oxygen. C3H8 from our earlier video is a ratio of 3 to 8, right? So 3 carbons to 8 hydrogens. There's no way of breaking it down. Opposite that, and we'll talk about this later, is molecular formulas. A molecular formula would be something like C6H16, okay? This is a 6 to 16 ratio, which actually can be simplified by dividing by 2 to a 3 to 8 ratio. So this is an empirical formula. It's its simplest ratio that cannot be broken down further. Molecular can be divided by a common factor, so we'll see that later. Working backwards, if we're given the percent composition, we can determine the empirical formula. So this is going to be a procedure that I will give to you on your unit test, but knowing this procedure is going to be very important for these last set of notes for us, okay? So a compound is analyzed and found to contain 25.9% nitrogen and 74.1% oxygen. What is the empirical formula of the compound? So the compound has nitrogen and oxygen in it, okay? And I need to figure out what the formula is. So here's what we're doing with these percentages. It says, assume that we have 100 grams of sample and convert the percentages to mass in grams. That means now I'll have 24.9 grams of nitrogen and 74.1 grams of oxygen. So we are automatically turning these percentages into grams. And then it says convert the mass of each element to moles by dividing by the molar mass. So I'm going to turn these grams of nitrogen and grams of oxygen into moles of nitrogen and moles of oxygen. So if I do that, I'll be doing 25.9 grams of nitrogen divided by 14, about 14 grams per mole of nitrogen. And if I'm doing that for oxygen, I'll have 74.1 grams of oxygen divided by about 16 grams per mole of oxygen, right? So I'm dividing by the molar masses. And so, give us a moment. So if I divide those two, I will get the moles of each of these elements here. So if I do 25.9 divided by 14, which is a molar mass of nitrogen, I get moles of nitrogen, which is 1.85 moles of N. And then for oxygen, if I do 74.1 divided by 16, I get 4.63 moles of oxygen, right? So these are the steps so far. I turn the percentages into grams, and then I turn those grams into moles. And then it says divide each mole value by the smallest number of moles calculated. So I have 1.85 moles of N, 4.63 moles of O. Between the two of them, my 1.85 is the smallest. Watch how I do this. I write N 1.85 like I'm writing a subscript for a formula. It's fake. O 4.63, and I divide each mole value by the smallest number of moles calculated. So 1.85 divided by 1.85, If I do this, 1.85 over 1.85 is 1, so N1. 4.63 divided by 1.85 is approximately, it says 2.5, okay? So I'm going to show you what to do with this right now, but it says 2.5, so it'll be like 2.5, and then it says round to the nearest whole number. So 1 is 1, 2.5 for right now and for the purpose of this video and for this class, that 2.5 is going to round to 3, NO3. And that is going to be the empirical formula. Okay? So, following these steps is how you arrive at an empirical formula. I turn these percentages into grams. I divide the grams now by the molar mass from the periodic table. I then divide by the smallest moles, and that gives me kind of the simplest ratio that I was talking about. This 1 is like this over here. This ends up being a 1 to 3 approximately. Okay, and then I kind of wrote it like a fake formula. You don't have to do that. You could just divide it over here and then get like a 1 to 3 ratio approximately. And then I write those as subscripts. So like a fifth step would be use these numbers as subscripts. Okay, for the formula. And that would be the empirical formula. And how do I know this is the empirical formula? 1 to 3 is the simplest ratio possible. I'm going to have more videos where I do more examples of this, so make sure you stay tuned. This is just a very quick introduction to this right now.